x. This is our x1 and this is our x2. So you can see here that one value is a positive value, then the other one is a negative value. So this positive value 4 on our curve, it's the value of x, it will be here. So this is the number which is supposed to be here. So we have 4 here. Then -1 will be here. This is the negative side of your Cartesian plane. So -1 here, and this is our positive 4. So we have found the values of A and B. These can also be written in coordinate form. So remember that coordinates are written in this manner. So if this is point A, the first value should be x, comma, y, like that. Then for point B, this one, B, x, comma, y, like that. Now, the two values that we are finding, these are the values of x. So at point A, this value of x is -1. So on A, we'll put, on x, we put -1. Then y, we don't have, so we just leave it like that. Then point B, so on our B here, the value of x we found was +4. So here, where there's x, remove the x and put the 4. Since it is the value of x, it is on the x-axis. So put +4, then the value of y, just put the y like that. Now, there's a simple rule. On the x-axis, the value of y is always equal to 0. So meaning here, we just say -1, comma, just to put a 0 here. Then on the other side, B, just write 4, comma, 0. So these are the coordinates at point A and point B. So the other thing that we try to find are the coordinates of point C. So to find the coordinates of point C, here we are supposed to firstly find the value of x here, like that. So you can see from the dotted line. So I need to find the number which is supposed to be here because it is the one which is taking me on this point C. Then at the same time, I'm also supposed to find the value of y here, like that. So we need two values. Up, the value of x here, then like this, we need to find the value of y. So to find the value of x here, we use the formula. You just get this part. Just go back to your quadratic formula. So on the quadratic formula, just get this part of the quadratic formula. So we have -b over 2a. This is the expression which we use to find the x value of the turning point, or the equation of the axis of symmetry. So to find the x value here, we write x is equal to -b over 2a, like that. So we already extracted our coefficients. What is our b here? Our b is -6. So let us get this -6. We replace it here. So we have, this formula already has a negative, so we put that negative. Then on our b here, we open parentheses, so we'll do this. So our b is -6. So that -6, we put it here, so it will be -6, like that. So just because your formula has a negative, it doesn't mean that you're supposed to leave out the negative in front of this 6. It's supposed to come along, like that, over 2. Then our a, so we can see from these coefficients that our a was 2. So where there's a here, we open parentheses and substitute the 2. Let us simplify. So we have negative times negative, we get +6 over 2 times 2, we get 4, like that. So our answer is 6 over 4, which can also be reduced further. So a number which can go into 6 and 4 without leaving a remainder is 2. So 2 into 6, we have 3. Then 2 into 4, we have 2, like that. So the x value of the turning point is 3/2, which can be written as a decimal as 1.5 if you like. So that's the x value. So we found the number here. This is 1.5 here, like that, which goes all the way to the turning point here. So the x value of the turning point is 1.5. We are also supposed to find the y value of the turning point here. So this y value of the turning point, since our curve looks like this, we also call it the minimum point of the curve. But if your curve is facing upwards like this value will be called the maximum point. So it changes depending on how your curve looks like. So here we're going to find the minimum value here, like that, on the y-axis. So to find that minimum value, we use the formula. We apply the formula. We say y is equal to 4ac minus b squared over 4a, like that. We are using the same coefficients, so you can see from here that our coefficients, our a is equal to 2. So our a is equal to 2, then our b is equal to -6, then our c is equal to -8, respectively. So these coefficients, we replace them in this expression. So we have y is equal to 4, then our a is 2, so we do that substitution. Then our c is -8 minus our b squared is, so we get -6, we replace it here, so we have -6 squared. Everything divided by 4. Our a is 2, so we put the 2. Let us simplify. So we multiply this. 4 times 2, we get 8. Then 8 times -8, we get -64. So 4 times 2, 8. 8 times -8, we get -64. Minus then -6 to the power 2 in brackets here. So this means -6 times -6, which will give us positive 36. Now everything divided by 4 times 2, we get 8, like that. We can simplify the top. So -64 minus 36, we get 100. So we have -100 over 8. Let us simplify. A number which goes into 108 without leaving a remainder. So we can break it down. Let us start by 2. So 2 goes into both numbers, into 108. So 2 into 100, we get 50. Then 2 into 8, we get 4. Like that. We can simplify this further. There's a number which goes into 50 and 4 without leaving a remainder, which is 2. So 2 into 50, we get 25. Then 2 into 4, we get 2, like that. So our answer is 25/2, like that, which can be written in form of a decimal as -12.5 when you divide. So this is the y value of the turning point. So y is equal to -12.5. So if we go back on our curve here, here on the y-axis, this number is -12.5, like that. So the coordinates of the turning point here at C, we have the first value of x we found was 1.5, then the y value is -12.5, like that. Now the last one is D. So point D is also known as the y-intercept, meaning the point on your curve, the point on the y-axis where your curve is cutting. So this curve is cutting at point D. So what number is here? So to find this number which is here, you just go on your curve here, you look at this number which is at the end, -8. So this -8 is your y-intercept. So point D is -8 there. So this is how we find all the important points on our parabola, or for the graph of the quadratic function. Thank you very much. So if you want more of my lessons, you can subscribe to my YouTube channel and also make your contribution so that you can access all the assessments. Thank you very much for watching. See you in another lesson.